Density of a fluid, or actually density of any object, is just its mass divided by its volume. If we, take a look at the canola oil picture, what's the density of canola oil? Well, you just need to know the mass of the canola oil inside this container, and you need to know the volume it's filling, and then you can determine its density. For density, we use this Greek letter rho. Rho, it's spelled R-H-O, rho. Um, and the density rho is the mass divided by the volume of whatever it is. The density of water is 1,000 kilograms per cubic centimeter. And the reason that, I'm sorry, per cubic centimeter. Yeah, wow, that'd be bad. 1,000 kilograms per cubic meter. And the reason it's exactly 1,000 kilograms per cubic meter is because this is what defines kilogram. And so we use water and the meter to define the kilogram. So, water is exactly 1,000 kilograms per cubic meter, or more specifically, 1 gram per cubic centimeter, which is what defines a gram. 1 gram is defined as a cubic centimeter of water at 4 degrees C. Um, And so, or 1 kilogram per liter. So you pick up a liter of water and you know exactly how much it weighs. I mean, what its mass is because it's a kilo. Um, so this is how we define this. And if you look at the density of other things, other fluids we have here, it's kind of instructive. Mercury is 13.6 times more dense than water. So mercury is really way up there. And one of the funniest videos I've seen is of someone throwing an iron anvil into a pool of mercury and watching the anvil bob around and float on the mercury. Ethyl alcohol is less dense. This is one of the reasons you can, and this is when we talk about gravity in beer and things like that, it's because alcohol is less dense than the water. Petrol is less dense, so it floats on top of water. Um, Olive oil is less dense. So all of your fuels that you use are are less dense than water, which is problematic if you have water collect in a fuel tank because the water goes to the bottom, and the bottom is where you're pulling the fuel from. And so if you get water in a fuel tank, you're trying to run your engine off of water, and most engines don't run really well off of water. You'll notice blood is denser than water. Seawater is denser than water, and the only time I have really, I'm despite being overweight, I tend to ride low in the water, and the only time I've had a relaxing swim was off the coast of Aruba, where because you're near the equator, this density is even higher, and I actually floated really well off the coast of Aruba and could relax in the water, and it was great. If you want to go to the Dead Sea, you can. The Dead Sea is even thicker, more dense, has so many minerals in it, and you can float on top of the Dead Sea without any problem. And then others, air is 1.29 kilograms per cubic meter. So when you think of air as nothing, it's clearly not, and it holds up most aircraft. So um, air is thicker. Um, the reason you have problems with carbon dioxide is it's denser than air on average. So if you have a lot of carbon dioxide, it's going to be going to the bottom. Carbon monoxide is going to be floating up. So it's going to be higher in the room, which is problematic as well. Hydrogen, you don't have to really worry about it. It's going to float away. Helium, it's going to float away. Methane, um, nitrogen. Nitrogen is one of the major components of air. Nitrogen's about the same as air. And nitrous oxide, denser than air. All right, and that's it for our bit on density.